The question is if f of x is given in the terms of limit n is tending towards infinity, and as you can see a series of sine is given here. So in this sine, the general term of the sequence is given as sine of 2 raised to power n x whole raised to power 4 whole divided by 4 raised to power n. Now as you can see, this is the first term, this is the second term, and this is the nth plus 1 term is given to us. Now further in the question they are saying g of x is a differentiable function satisfying g of x plus f of x is equal to 1. After finding g of x, we have to find the maximum value of f of x root over f of x plus root over g of x whole raised to power 4. So let's start with f of x only. Now as you can see, n is tending towards infinity is given and this sequence is given. So I can feel that this kind of telescopic series is forming here. So let's start with the first term only. Let's call this first term as t naught here. So t naught, I'm writing this as sine raised to power 4x. Now in order to make this as a telescopic series, why I'm saying? Because n is tending towards infinity is given. So I'm going to do one thing. I'm going to take the first term. I'm going to rewrite the first term or manipulate the first term in such a way that the difference of two terms will occur. If the difference of two terms is going to occur, every term I'm going to write in the same way. You will see alternate cancellation. So I'm going to write this as sine square of x multiplied by sine square of x. Now the second term, I'm going to keep the first term as it is, sine square of x multiplied by, I'm going to change the second term, that is 1 minus cos square of x. Now I'm going to multiply again sine square x inside. So sine square of x again will get here, and here we'll get this as sine square x multiplied by cos square of x. And remember students, the objective is I'm going to create the difference of two terms. So here I'm going to multiply by 4 and divide by 4. So we'll get t naught as sine square of x minus 1 by 4 sine square of 2x, as you can see. Now I think I can generalize for t1 here from t2. Let's say this is t1 and so on. The term is varying from t naught to t of n here. The total number of terms will be n plus 1 here. So here I can say if I write all the terms starting with t naught till t of n, you will see alternate cancellation. So t naught will be sine square x here minus 1 by 4 sine square 2x. Similar way I'm going to generalize t1. So t1 will be sine square, as you can see 2x will come here and 1 by 4 will come here because 1 by 4 is already multiplied in t1. Minus 1 by 4 square will come here and we'll get sine square 2 square x here. Similarly t2 I can write this as 1 by 4 square sine square 2 square x minus 1 by 4 cube sine square 2 raised to power 3 x here. Similar way I can write till t of n. So t of n will be, now we can generalize here. For the second term the power of 4 is coming as 2. For the first term the power of coming as 4 is 1. So for the nth term power of 4 will be 4 raised to power n. Now we'll get here sine square 2 raised to power n x minus 1 by 4 raised to power of 1 more from the term. So 4 raised to power n plus 1. Here we'll get sine square 2 raised to power, and here we can generalize n plus 1 into x here. Now as you can see, the moment you add all this term, you will see alternate cancellation. So as you can see, minus 1 by 4 sine square 2x plus 1 by 4 sine square 2x will cancel out. Similarly, you will see this alternate cancellation. So if you cancel out, you will get something like this. The moment I add all this, I'll get f of x. Then I'm going to take the limit. Now f of x will be equal to limit n is tending towards infinity. As you can see, only two terms are remaining, sine square x here minus 1 by 4 raised to power n. Here we'll get sine square 2 raised to power n plus 1 into x. Now, if you observe one thing here, that is any sine value will vary from minus 1 to 1. In this case, it's sine square. So this will vary from 0 to 1. But in general, I'm writing this value will be varying from minus 1 to 1. And then as limit n is tending towards infinity, if I'm taking, I'll get here finite. Finite means from minus 1 to 1 any value upon infinite. So I think finite upon infinity will be equal to 0. That means directly this limit will be equal to 0. And from here I'll get f of x. So f of x clearly will be equal to sine square of x. Similarly, g of x I can calculate using this equation here. So g of x can be written as 1 minus f of x, and then g of x will be equal to here cos square of x. So I got these two functions. Now that I got these two functions, I can calculate the maximum value of the given expression. Let me erase this part. So the maximum value of the given expression I can calculate immediately by putting f of x and g of x in the given expression. So they are saying root over f of x, that will be sine of x here, and root over g of x will be, that is cos of x, and whole raised to power 4 they are saying. Now in general we know the range of a sine of x plus b cos of x. So I think the range of this will be minus root 2 to root 2. Now they are saying we have to find the maximum value of this. So maximum value occur at root 2 or minus root 2. If you take the power 4, the answer will be same. So the maximum value will be root 2 raised to power 4. So if I take the power 4 here, the answer will be 4 here. So the final answer is 4, the maximum value of this expression. This will be our final answer, and that will be all.